Hi guys. What we're doing today is we're beginning right angle trigonometry. So we're going to start with the absolute basics of trigonometry. Okay, so first up, trigonometry. What exactly is it? Well, it's just the study of triangles. So in this topic of trigonometry, we're always dealing with situations that involve some sort of triangle. So, and in particular for today, these triangles actually have to be right angled. So there is trigonometry for non-right angled triangles, but for today we're only dealing with the right angle situations. Okay, so one of the main words you need to remember is the word hypotenuse. The hypotenuse of the triangle is the longest side of a right angle triangle. Also, this side is directly across from the right angle. Okay, so an example of this is down here. I know that this side is my my hypotenuse because it's directly across from this right angle. So I see the right angle here. I think straight across, there's my hypotenuse. Over here, there's my right angle. If I go straight across from my right angle, I get to my hypotenuse. So that's the idea of a hypotenuse. It's just the longer side as well. You can see that this side is a lot longer than that one and that one. This side is longer than that one and that one. So that's pretty much the idea. Pretty straightforward. Okay, so the next one is the opposite side of a right angle triangle. So that's the side which is directly across from the given angle. So in these triangles that we're dealing with, we're always going to be given some sort of angle, and that's not going to be the right angle. So make sure you don't get that confused. Okay, so down here, there's my given angle, my 35 degrees. I gave that one to you. And if we go directly across from that, we get to our opposite side. So that's the idea. Over here, the given angle is this theta here. We'll get to that in a second. If I go straight over to the other side, there's my opposite side. So again, opposite side is pretty straightforward. Then we've got the adjacent side. So this is the third side. So that was the first, that's the second, this is the third. So the adjacent side is the side which is next to the given angle. The word adjacent literally means next to. So we've got to think which side is next to the given angle, and it's definitely not the hypotenuse. So don't get the hypotenuse and the adjacent sides mixed up. So here, here's my given angle. I look to see, well, what sides are next to this angle? Well, that and that are next to it, that not the other side. Now this one up here, that's my hypotenuse, so it's definitely not that one. So therefore it has to be this one down here. There's the adjacent side. Over on this one, here's my given angle. This is next to it, and that's next to that angle. But this can't be it because that's the hypotenuse. So therefore the other side, this one, has to be my adjacent side. So what I'm doing there is pretty much telling you how to label the sides of a triangle using a given angle. So it's a really important skill for what we're doing today in trigonometry. Okay, so moving on, the next one is theta. So theta is this symbol right here. It's a Greek letter which represents an unknown angle. So here I've used my theta. I'm pretty much saying that I don't know the size of this angle, but I'm still giving it to you, but I don't know its size. I haven't measured it yet. I knew this one, but I didn't know this one. So theta is just a symbol that we use to represent an unknown angle. Okay, so moving on. The next word I need you to know is the word trigonometric ratio. So fractions which divide certain sides of a right angle triangle. So the key word here is fractions. So we're definitely dealing with fractions here, and we're dividing certain sides. So here I'm using these labels of opposite, hypotenuse, and adjacent, and I'm giving you these ratios. So the ratios that we're dealing with are the sine ratio, the cosine ratio, and the tangent ratio. Okay, so first up, the sine ratio. So here we're dealing with sine of theta. So for short, SIN instead of SINE. So sine of theta is opposite over hypotenuse. Next is cos theta, which is cosine. That's equal to the adjacent divided by the hypotenuse. And then lastly, the tangent ratio, or just tan for short, and that's equal to the opposite divided by the adjacent. So each fraction has different sides to each one. So you got to kind of remember these. And the way to remember it is to think SO katoa. So SOH, CAH, and TOA. So that's just a quick way to remember it. Just think SO katoa every single time. Okay, so moving on. So it's important that you remember those ratios. Okay, so the next one also is degrees, minutes, and seconds. Now, a lot of people forget this. Okay, so this is to do with angles. So angles are measured in degrees typically. So tick, we're usually pretty good with our degrees. We know what they are. But degrees are really tiny, but you do split degrees up. So every single degree contains 60 minutes, just like an hour. I know you're thinking to yourself, oh, but this is angles, not time, but it's the same idea. So a minute could be a part of a degree or it could be part of an hour. It's the same sort of thing. And each minute contains 60 seconds. So it's just pretty much similar to time. So don't get time and angles mixed up, but they do have similar units. Okay, so we'll get to that in the future. Okay, so let's get a few rules to remember. We can use these trigonometric ratios, sine, cos, and tan, to determine unknown side lengths and angles of right-angled triangles. So if I can give you some information and you can use that to figure out some unknowns about these triangles. Okay, so a bit of a note here. 2 pieces of information must be given about your triangles in order to be able to use these trigonometric ratios. And the 2 pieces of information do not include the right angle. There always has to be a right angle, and then I also have to give you another 2 pieces of info. So yeah, really important to remember this idea that we're only dealing with right angle trigonometry, so there has to be a right angle. Okay, so moving on. So first one, determine the value of each unknown pronumeral to 2 decimal places. So we're trying to determine this x right here. Notice how many pieces of information did I give you about the triangle? And the answer is I've given you 2. I've given you that angle and I've given you that length. So because I've given you 2, that's enough information to be able to find this x. So that's the idea behind thinking that you need at least 2 pieces of information. Don't worry about this yet. I'll come back to this. Okay, so let's go through a bit of the working. Apologies for it being a little bit small, but we can zoom in. Okay, so here's our question again. I want you to think to yourself, firstly, you need to label the given sides. So the sides that I've given you are this x and this 15 meters. I haven't given you anything up here, so don't worry about that side. So only worry about these 2. Okay, so here's my given angle, and I got to think to myself, what are these? What is my x and my 15 meters? What are their labels? So I think to myself, firstly, well, the 15 meters is definitely the longest side. It's opposite the right angle. So therefore, that is my hypotenuse. So I put an H there. And also, this x right here, that is on the other side, which is next to my given angle. So therefore, that must be the adjacent. This one over here is my opposite, but I don't have anything there, so I don't worry about the opposite. Okay, so now, this is the tricky part. You need to think to yourself, which of the ratios, sine, cos, or tan, do I need to use for this triangle? So I think so, ka, toa, and I need to use one of these ratios, 1, 2, 3, the one that applies to H and A. So I look at this and I think cos is my answer because it uses the A and the H. The other ones don't use A and H. So cos is my ratio that I need to pick. Okay, so what I do, I pick cos. So there's my picked ratio, and I write it out. Cos of theta equals adjacent over hypotenuse. So this is directly from the definition of cos. So it was up here. Where is it? It's right here. So there's my cos. Okay, so let's come back down here. So I rewrote that. And I think to myself, now I substitute in. So my theta is my unknown angle, but I do know my angle. It's 46 degrees. So those 2 change to each other. My adjacent was x. So adjacent, the top one becomes an x. And my hypotenuse down the bottom is 15. So my hypotenuse changes to a 15. I pretty much just substitute them straight in. So that's my first line of working to get that. Really important to be able to get to this stage. And now we look at this equation and we think, how do we get x by itself? Well, x is with a 15. We've got to move the 15. The 15 is dividing, so we times both sides by 15. And then once we do that, our 15s cross out, leaving us with just an x by itself. And we get over here 15 times cos 46. That's what our x is equal to. You shove that straight into a calculator and you get your value of 10.42. 2 decimal places, which our question required. Okay, so that's the first question done. Now that question is unique because you get x on the numerator. So see here in our fraction, x is on the numerator. So that question is going to be quite different to the ones coming up, because in the one coming up, x isn't on the numerator anymore. X is on the denominator now. So when we follow that sort of process, again for this triangle here. So let's try it again. So first up, I've labelled my sides O and H, following the correct procedure, because that's straight opposite. And this is my hypotenuse, the longest side. So O and H means our sine. We have to use sine because that was SOH. And then we substitute in. So our 31 goes in for our theta. Our opposite's 14.3 and our hypotenuse is x. And then from there, we need to get x by itself. Now, we still need to multiply both sides by the denominator. Really important to remember this part. So I'm going to times my denominator x, so times both sides by x. And we've got to think when we do that, that x cancels with that x there, so those two scribble out. And then this x times is over here. So we get x times sine 31 equals 14.3, because that's what's left over. And then we think to ourselves, how do we get this x by itself? Well, we have to divide, the opposite of times is divide, so divide by sine 31. So we shove this in for our answer, and then we put that into our calculator and we get our final answer, because remember our sine 31s will cancel in that situation to get x by itself. Remember guys, if I'm going too fast for you, just replay this sort of thing. You can listen to this over and over again to make sure that you understand how to get these answers. Okay, so that is the situation when you've got x on the denominator. You have to multiply both sides by this x here because you have to remove that denominator. Really important to remember that. Now, the last sort of question you're going to have to deal with is when you're finding an unknown angle. Before, we were finding an unknown side, and here, an unknown side. But down here is when you're dealing with this unknown angle. We know it's unknown because I just give you a theta. I don't tell you what that angle is. So what do? Well, we label the given sides again. So here we've got our opposite. We go straight across from our theta, our given angle, and we get to our opposite side. So there's our O. And then we've also got, well, this side down here is the longest side. That's our hypotenuse. But there's nothing there, so we don't worry about the hypotenuse. So we've got the opposite, and this must be the adjacent side, the one that's just next to it. Okay, so we've got to think, what uses O and A out of SOHCAHTOA? TOA? So at SOHCAHTOA, the one that uses O and A is TOA. So we make sure we're using tan. So we rewrite the ratio for tan. So tan is equal to opposite over adjacent, and we substitute in. Now theta doesn't change, it's just the theta, but the opposite is 14 and the adjacent is 13. So it becomes 14 over 13. And now we deal with this situation here. Now our unknown is this theta. We need to get this theta by itself. Now at the moment, what is that theta with? What do we have to move away from theta? We've got to get rid of this tan somehow. We've got to scribble out that tan. How do we remove the tan? Well, we have to think, what is the opposite of tan? And the answer to that is what we call inverse tan. So it's like a tan with a -1. So inverse tan is literally, it looks like that, tan with a little -1. So we do that to both sides, and literally the inverse tan and tan, they're opposite, so they cancel out just like that, and you're left with theta. And that's what we want. We want that theta by itself. So we apply that tan -1 to both sides. When you apply it to the 14 over 13, it looks like that. That's what it needs to look like in your calculator. Tan minus 1, and then in brackets 14 over 13. That's what you need to put into your calculator. To get the tan minus 1 in your calculator, press Shift Tan. Really important to remember that. Okay, when you do that, when you put this whole thing into your calculator, you end up with this. Now that is the decimal version, which sometimes they want if they want you to round it to the nearest decimal. So that could be like 47.12. But if they want it in degrees, minutes, or seconds, you have to press this button in your calculator. So have a look for it. I'm sure you'll be able to find it. And it shows you, when you press that, it shows you the degrees, the minutes, and the seconds. So I'm going to round it. I know I didn't specify in the question, but I'm going to round it to the nearest minute. So the idea is to round it to the nearest minute. I look at my seconds and I think 15.95 seconds. I got to think, if that's going to round up, it's going to be more than halfway of a minute. So halfway is 30 seconds. So because it's below 30 seconds, that's going to round down. So the 7 minutes is going to stay 7 minutes. So your final answer there is 47 degrees and 7 minutes. Okay, so good luck with the questions, guys. Come back to these notes if you're having trouble, but also let me know as well. I can help you out. Good luck, guys. Bye.